I will start the transmitter, and as soon as the system is started, I will also enable the Bluetooth application.
Okay.
That will actually show me what the drone system is doing right now. So I don't have to just assume that it's ready. It will tell me if it's ready or not. It will tell me everything it's doing. So I have control over what it's doing, and then we will start with 20% duty cycle,
Okay.
which means that the system will not fly. It will not really show any movement,
Right.
but just to make sure that every motor is running, every controller is right good, and then we will increase slowly the speed of the motor, the maximum speed, 30%, 40%, 50%, and 60%.
Okay.
So what I will do is I will just increase in using my Bluetooth application. I will just increase the speed, and as soon as I increase the speed, it will automatically adjust the gains and offset of every motor, because every motor is different.
Right.
So I have the test data over here, which I did before. So
You've gone through and calculated all that?
yeah. I mean,
Or not calculated, but measured, right?
yeah, measured from here,
Yeah.
not this stuff. But
Yeah.
these guys over here.
Yeah, you don't have an MCAS system on this, do you?
Yeah, I
That would
don't
be
have
bad.
a
That would be
system.
bad. Single
Yeah.
point failure, right?
Yeah. So then I will show, after the manual controller, I will
Yeah.
actually show the PI controllers that I developed for this system.
Okay.
First of all, we will start with zero constants, meaning it will not do anything.
Okay.
But then as soon as I increase my P values, P controller constant, and I controller constant, you will see.
So this
how
will see the effect of
Yes.
your this would be your local loops.
Yeah, local loop.
Right.
And the automatic controller, the PI controller,
Yeah.
will actually take consideration of the sensor that's sitting inside. So it will not. So as soon as I switch from manual to automatic,
Yep.
these will not directly control the motors.
Okay.
It's not directly controlling the motor anyway. There is a controller, manual controller.
Yeah.
But these will be my set points then.
Right.
So and the process variables will be from the sensors. So
Right.
it will be very the whole mode of operation will change from just one.
Yes. Okay. So your set point will be a system set point. Your controller will then control all four
Yeah.
motors to
Yeah.
achieve that local system
Yeah.
set point.
Yeah.
Yeah. Okay.
So let's just start.
Let's do it.
Yeah. So I will just power on the system,
Okay.
and
And what's our current limit set for now for this test?
for now it's 5.5 meaning
Okay.
11 amps
Okay.
for dual power supply.
Gotcha,
I have
yeah.
that in tracking mode.
Right. Dual supply, right?
Yeah.
Okay.
So over here it's showing what it's doing.
Right.
So it's showing me, it's calculating the base altitude, and then it's calibrating. So my offset or zeroing for calibration is 133.080. So that is my zero
Okay.
for the calibration
Right.
aspect. So my pressure sensor will take this as zero.
Right.
So
You'll be offset from that.
Yeah.
Okay.
So if I want to go up, then it knows
Above
what is-
that, yeah.
Above that and below that. Okay,
Right.
so that is on.
Okay.
Now you can see that the system is on, but the propellers are not spinning.
Yep.
Or it's not doing anything because I have a state machine inside
Okay.
that tells that if the receiver is not connected,
Right.
it should not just start.
Okay.
So I will just turn on the receiver, and what will happen is I have programmed this transmitter
Yeah.
as such that it will not turn on, it will not transmit any signals unless and until I have e-stop and calibration mode set.
Right.
So that even if it turns on, the propellers doesn't turn on automatically.
Safe state.
Yes, safe state.
Okay.
So that user doesn't have to do the thing. So I'm just setting, and also the throttle should be 0.
Okay.
Then only the transmitter will be operating.
All right.
So now everything is good. Now if you can listen to, hear that sound.
I can hear it. Yeah.
Yeah, it shows that now it says that e-stop is engaged right now,
Right.
which
and
means
so you're gonna have to turn that off.
yeah, so
Right.
I will turn off the e-stop, but
Okay.
my calibration mode is on. So once I start, e-stop is off.
Yep.
Then it again calibrates the whole thing.
Yep.
This is when the
Just the
this-
glare from the light. Yeah.
Oh, this is when the system actually gets its 0 position.
Okay.
Now it tells that user should move away.
Okay. Right.
Yeah, because the system is just about 1 click.
Right.
So now I will go to manual control.
Okay.
Now remember the speed is 20% duty, so it's just to make sure that every motor is working.
Right. And no local control at this point.
No,
Okay.
no local control.
So we're just spinning the
just
motors.
spinning the motor.
Right.
So
Okay.
So now I can see that everything is working fine.
Good.
So now I can turn on the speed. Turn up the speed
Right.
so that
You're just exercising the motors at this point,
yes.
and then
Now I'm just seeing that okay, everything is good. Now I can actually turn up the system, and I can.
but you don't want to get achieve liftoff at this point because
No.
you have no control. So
No.
you just want to spin them up before you have enough thrust to
Yeah.
actually lift off the ground. Okay. Or
So that is 20%. I
Okay.
will just increase the speed. So now we have different buttons over here.
yes, pre-programmed
Yeah.
for sequences that you've
Yeah.
already.
So-
Okay.
Yeah. So every button does different stuff, and these are all tuning buttons.
That
So
you've already determined. You've predetermined
Yes.
what your PI
yeah.
are for each of the motors.
Yes,
are.
yes.
Right. Okay.
So now I will just increase the speed over here.
Okay.
So it tells that motor speed is 30% 0.3,
Okay.
and all the gains are adjusted as per accordingly.
For each motor through this was empirically determined through collection of data and observing.
Yes.
Okay.
Yes.
The result.
These are these
Yep.
guys.
That's fine. Yep.
From 30%, 0.998, 0.78, 978, 0.9890. So
Good.
it's
Yeah.
it's same thing.
Yeah.
So they just
Okay.
adjust it automatically. Now it's 30%.
Okay.
It will still not display any significant movement.
Okay.
But the motor speed will be increased.
Okay.
accordingly.
So
So
10% faster than we were on our
yeah,
last
10%
test.
faster
Okay.
Then, but it's not, it's not showing any usual price. Once I turn up the speed,
Yeah.
it will actually, you will see what it can do. So right now it's just doing with 30%, which is not really exciting. But now I will turn up the system at 40%. So that is 40%, and the gains are changed from these guys to these guys.
Okay. And we saw a little bit of a burst there from that.
Yeah, because of the manual control.
Oh, okay.
And
Gotcha.
also because for some reason where my Bluetooth interferes sometimes with the
Oh.
receiver.
Okay.
Now I have no control over that stuff.
Right.
Um,
This is
but-
why you turn off your phones on takeoffs and landings, right?
Yeah.
Right.
Yeah, good stuff. It's important. Okay, so now it's 40%. Now you will see somewhat. You will see the. So first of all, this is to go up and down.
Yeah.
This is to go right. This is to go left.
Okay.
This is to go forward.
Right.
This is to go backward, and this is to yaw right
To
and yaw
spin,
left.
right?
Yeah, but because of the setup,
Right.
it cannot yaw.
It'll
So
pull all the desks into.
yeah, it's not going to happen.
No. Okay.
So yes, so right now it's 40% duty. Now I will just tune up the system. Now you can see the tension on the spring
Yeah.
is way less than what it was, before.
Right.
It was resting.
Not enough to lift off still, but,
No,
which is
not
a good
enough
thing
to
for
lift.
for now.
But,
Yeah.
but good enough to see how the system behaves.
Yes.
So if I go right, you will see it tilting over there.
Yeah.
And if I go left, you can see that the whole thing
I do,
is
yeah.
over there.
Good.
Then if I go forward, then the first and the third motor should slow down, and then it just moves tilts
Yep.
forward. it doesn't tilt it perfectly because the tension on the springs
And no
you know,
local loop control either,
yeah,
right?
yeah,
Yep.
and this
Back.
is to go backward, but because the tension is just so quick, I just have to. Okay, well that was because the
Right.
Bluetooth was interfering sometimes.
Oh, okay. So can you do a yaw?
Yeah, I can show, but you will not see because
We won't see
the
much.
it's
Okay.
too tight for the system.
Okay, let's see.
Okay. Now this is doing. If you can hear the motor
Yeah.
screams less, uh, but you,
So every even motor would speed up, odd motors would slow
yeah,
down, and vice
yeah,
versa.
Yeah,
Okay.
but you will not see
Yeah.
here. But it's doing it.
Yes.
Because I checked with
Yeah.
tachometer. Now I will. Uh, Now I will actually turn up the system to 50%,
Okay.
and that will really show you how this, how the
With no local loopback
no,
control
no
either.
local
Okay.
loopback control. Now you can
Yeah.
see the easy.
Oh yes, definitely.
Now it just goes somewhat up,
Yeah.
but not really that much. But this is a good point where I can really see what it does for left,
Right.
right, then forward and backward. It's just bouncing everywhere.
Yeah. Good.
So this is just 50% is a good point to release most of the tension,
Yeah.
but the system is not really hovering.
Right. You were saying you need about 60 to start.
Yes.
Okay.
So now I will go to 60%.
Oh, don't you want to put in your KPs and KIs now?
No, I will first do the manual and then I
Oh.
will show the.
Okay. So this could go.
Yeah, this could bounce.
Oh.
But,
All right.
but we will see.
Take a couple of steps back when you do this one.
Yeah, okay. So 60%. This is
All right.
not, and also for 60%, 11 amps is not enough.
Oh.
No, 11 amp is not enough. But forgot to.
We can get a second supply in here. That wouldn't be a problem.
Okay, but right now we. Just,
Okay. Certainly. Yeah.
So 60% you can
Yeah.
see. So now you can see the difference of manual control.
Yeah.
Even the motor gains are adjusted. The system is not stable enough.
Right. Right.
Because of the local, because it's not really reliable source. But if I go left or right,
Oh, definitely. Yeah.
now you can see.
You can hear and see it.
Yeah, you can hear and see. But if you see, look, the motor
Yeah.
1 and 2, they are.
Those are the
actually-
left side motors. White on the left, red on the
Now,
left.
You can see that they are really in good shape. I mean,
Yeah.
they are really spinning at very near rate.
Yeah.
And to go up,
That's
Yeah,
3 and
that's-
4.
yeah, that's 3 and
4 is the red on the right. 3 is the white on the right.
Oh no, 4 is the white on the right,
Oh, okay.
and 3 is red. Now to go forward. Now it because the the tension on that wire is more than the first one. It actually tilts over there, but
Yeah.
more or less it's doing what it's supposed. Now this is coming to us.
Right.
It will not a good.
Oh, no.
We should run if it's
This is why we've got it tied down, right? Okay.
Yeah. So right now the power is enough to actually just lift off a little bit.
Good.
Now this is where I have the current limit set up. So
Okay.
it cannot really go up because it requires too much power.
Okay.
Now I will show now I will just turn on the system.
The control.
Turn down the system on 40%, and yes, automatic control.
Okay. So, semi-autonomous at this
Yes,
point, right?
semi-autonomous,
Okay.
but with 0 PI value.
Oh, okay.
So it will not do anything, and that is so when I tune up the system
Yeah.
to I will press this these buttons over here.
Yeah, why don't we just go to that point now?
Okay, we can go.
Yeah.
So if we go, I just turn off the system. So I'm just roll KP is set to 0.01.
Okay. Okay,
over
0.1,
here.
yeah.
Yeah, and pitch KP is set to also 0.01.
Okay.
No integral. No, for now, no integral
Okay.
point. I mean controller. Now I just go up. This is in manual control.
Okay.
Now I go in automatic control over here.
Okay.
Now it says that it's automatic control.
So now it will be more stable, but not as stable as it can be until integral is introduced.
Yes.
Okay.
So right now if I roll,
Okay.
if I keep my, now the problem is it cannot really roll too much
Okay.
because of the setup.
Right.
But if I put my throttle level to more,
Yes.
then it will eventually turn off the motor 3 and motor 4
Okay.
if I go right. If I go left, then it will eventually turn
Turn
off
off 1 and
motor
2.
because the set point is too much and the
Right.
error is too much, and I'm not,
Right.
it's not really rolling because of the setup.
It can't roll.
Yeah, it cannot roll.
Yes.
Once it rolls, it actually adjusts itself. You will
Okay.
see. So I go right now.
So we'll see the motors eventually shut down
Yes.
on the right.
Yeah.
Yeah. And then if you go the other way, the opposite will happen. The other motors
Yeah.
will shut down. Okay. Okay.
Now I also set the pitch roll value.
Okay.
Pitch KP value. So if I go forward or backward, the same should happen for motor 1, 3 and 2, 4. So if I
Okay.
go forward, now it takes time.
But they
because
eventually shut
yeah.
down, yeah. And then the ones on our side will shut down.
Now
when you
if I
the
go
other-
backward.
Yes.
So that is how the drone
Yep.
aerodynamics works.
That makes sense, yeah.
Yeah. Now the issue with this system.
Sorry to interrupt. So it makes sense for this test, but in reality, you would never shut those
you would
down.
not do that.
There would be a threshold, a
Yes.
limit where they're spinning, but
Yes,
yeah, okay,
there will be a threshold,
yeah,
but also this should not happen if the wires are not clear.
right. But I mean, even if it were to happen,
Yeah,
you would
yeah,
never
yeah.
want a motor to stop.
Yes, yes,
Right. Okay.
yes.
Good.
I have that control in manual control.
Okay.
I can actually limit how much it can go off.
Gotcha.
I can limit it, but for automatic control, it's just I don't find it very. I haven't done it yet.
Okay.
I am yet to do.
Oh yeah, that's no worries.
So that is 40%.
Okay. And
Now we will see really in 60% mode.
okay, we don't want to introduce integral at this point.
Oh, we can. So I will just increase my KP value right now,
Okay.
and so it's 0.02, and KI value will be, let's say 0.0001.
So what is your optimal KP value and KI value?
That is my optimal.
0.02, and then
Yeah.
your KI is
Yeah.
0.0001.
Yeah, optimal
Okay.
is, pilots can really define what their optimal. The whole point of this system was to have that programmable. So if there is a big, larger drone, then you don't want, that transition to happen too fast.
Correct. Yeah.
For testing purposes, my goal was to make it fast enough to see the results,
Okay.
so that I don't have to wait, 30 seconds to turn the system
Right.
off.
Exactly. Yeah. Yeah.
And-
And go through the
but-
whole pre-flight checkup again. Yeah.
Yeah, but in reality, you can hook up this system to even a smaller drone,
Yeah.
and then you can tune up your KP and KI values accordingly. If you want to create a racing drone, then your KP will be higher. All
Sounds
these kind
good.
of things.
Yeah.
So that is the whole programmable aspect of it. You can see things.
Okay.
So right now, my roll KP is 0.02. My roll KI is 0.0001.
Okay.
And I will do the same for pitch.
All right.
And,
Oh yes. So,
So
and then you'll have different. Yeah, it'll be the same KP and KI
Yeah.
for pitch as well. Roll
yeah,
and pitch.
and
yeah.
but the time it takes for motor to turn off, it will be different because
The integral. Yeah.
because of the integral, but it will be much more smoother.
Right.
And okay, so we'll just start. It's 40% right now. Now I modified my KP and KI for pitch and roll.
Okay.
So I'll just go up. It's automatic mode. So now I go left, right, sorry. Now you can see how fast the turn.
Yeah.
Um,
That took to turn off.
yeah. Previously it was just T, but now it's integrating the error,
Right.
so it turns off. I decrease the amount of time it takes for my error to adjust,
Okay.
and also the oscillations are, I can't see really oscillations happening
No.
because of the test setup.
Right.
Um,
But you'd have to be able to hook it up to a tachometer
Yeah.
and plot those
Yeah,
versus
yeah.
time to see that
yes.
in real time. Yeah.
Now I go left. Now you can see the motor 1 and 3
Yeah.
are
They eventually stop. Yeah.
yeah. So controller values and controller values adjust how fast they can turn off and how smooth they turn off,
Yeah.
so that system doesn't have sudden jerks and unstable movement.
Right.
That's the whole point of this exercise.
Okay.
If I go up, forward, motor 1 and 3 will eventually stop
Yeah.
because it's pitch, and also if I go back, it will be motor 2 and 4. Also, I should mention that these motors, they are not spinning on same direction.
Right.
They are different, and propellers are also different. So motor 1 and 4, for example, think about this. There is a normal line over here. Motor 1 spins clockwise.
Yeah.
Motor 3 spins counterclockwise. Motor 2 spins counterclockwise, and motor 4 spins clockwise. So it just, they all direct on the same line. They want to go.
So the motors on the white arms spin
Yes.
in one direction. The
Yes.
motors on the red arms spin in the opposite.
Yeah.
Yeah. Okay.
That actually creates the equilibrium.
Right.
So the quadcopter doesn't go. It's not unstable, so it
Yeah.
doesn't yaw in one
Yeah.
axis.
And in fact, that's what you use to control yaw, right?
Yeah, and
Okay.
so even though the motor 1, motor 3 and 4 are actually stopping, there is a counter force on the opposite side. So the rotational moment of inertia created by 1 is countered by 2. So it doesn't spin, it doesn't spin in the air.
Right.
It just goes left.
Right.
It doesn't spin and go left.
Gotcha.
So that is also one of the control aspects. Now if I turn up into 60%.
Now
Yes.
we're going to get liftoff now, right?
Yeah, now we will get lift off, and that is 60% motor
Good.
duty. Now this is in automatic mode.
Okay.
So we should
This
see.
is the moment we've been waiting for right here.
Yeah. Oh. Now you can see. Oh, the Bluetooth interference again. Sorry for that.
No worries.
So now you can see if I go now, the system is not really very stable. But oh, by the way, I only activate the controllers when I change some of the settings.
Okay.
It's because of the testing issues. I didn't want it to just, so I have limited when can they start.
Okay.
The reason for doing that was I wanted to see the reaction of only one controller at any time.
Oh, okay.
So
So do we have all four that can be implemented? Like, can we get it to hover where it's stable?
So I have to change the program of that one. I don't have it right now, but I have to do it.
Okay, so what's happening now? Only one controller?
No, right now it's just taking the height into account. It just wants to go up.
Oh,
That's what
okay.
is happening.
So there's no stability right now.
No, no. But
Oh,
I
okay.
have to change this. For example, see this. So as soon as I change my pitch, my to go forward,
Right?
it will turn off the motor 1 and 3. Then you can really see what it is doing and how it is controlling the truck. So you can see how it's it's difficult to explain, but it's the same thing but with the more lift off kind of thing.
Right.
The reason for not really enabling every controller right now was that I was doing my testings and I wanted to see how each controller worked with each input and how each motor
Oh, okay.
speed.
So how far off do you think we are before we can try that test?
I don't have my laptop right now.
Oh, okay.
Yeah.
But that
but
would
I
be just enabling it.
Yeah,
pretty
just
much.
enabling it, just commenting out some stuff.
Okay.
So I just comment the if and else statement.
Right.
And that should just happen. I mean, I tested it all controllers happening on oscilloscope,
Yeah.
but I don't have it right now. It's not enabled right now.
Okay.
Yeah.
That's good.